The story begins thousands of years ago in a small workshop in Greek. A mysterious bronze device, the Antikythera Mechanism, was built around 100 BCE. Scholars now call it the world's first analog computer. Its gears could predict eclipses and track the motion of planets. Humanity's fascinations with the machines that think had just begun. Fast forward to the 17th century, Blaise Pascal's calculator and Leibniz step reknocker turned math into mechanics. For the first time, numbers could move with gears. The idea was simple yet revolutionary. Let the machine handle the calculations. That's our old habit. In 19th century, Charles Babbage dreamed of an analytical engine, a programmable machine. His collaborator, Ada Lovelace, envisioned it going beyond numbers, perhaps even composing music through never completed. This dream planted the seeds of modern computing. Then came 20th century. Bulky room-size ENIAC machines filled with vacuum tubes, later replaced by transistors in 1950s. In 1970s, Intel's microprocessors changed everything. The computer shrank from room to chip, entering homes, classrooms, and eventually our pockets. And here's where I myself, Aijaz, step into the story. As a researcher in AI, I've watched these machines evolve not just in size but purpose. What once solved math problem now detects emotion, teaches students, and even assists doctors. My own work is in deep learning and student engagement detection shows far we have come. From gears to bronze algorithms that have sense of learners engaged or drifting away. But the journey doesn't end here. At the edge of science lies in the quantum computer, unlike the classical bits, which are 0 or 1. Quantum bits, qubits, can exist in multiple states at once, thanks to superpositions and entanglement. Imagine solving a problem in minutes that would take today's fastest supercomputers thousands of years. Quantum computing promises breakthroughs in medicine, climate modeling, and AI itself. Standing here today, I feel like I'm in the middle of a bridge. Behind me, footsteps of ancient inventors. Before me, the glowing uncertainty of quantum future. One day, perhaps, very algorithms I develop for education may run on a quantum machine, transforming learning beyond anything we imagine. The story of computer is not just about machines. It's about us, our curiosity, creativity, and courage to dream. From the Antikythera mechanism to quantum processor, one truth remains: every generation builds tools not just to calculate, but to understand the universe and ourselves.